I'm Susan Danielson, and I've been teaching algebra and trigonometry with a graphing calculator for the last several years. In this video, we're going to explore the features of the TI-83 calculator that you would use most often when working problems in algebra and trigonometry. I will present some examples, and we will work through all the keystrokes and look at all the menus that you would need in order to answer some questions about those examples. To best use the information on the video, I would suggest that you get your calculator out and work through so that you can find the keys in the menus as I'm demonstrating them. In the process of doing the examples, I will refer to analytical work. And by that, I mean the paper and pencil calculations that you would need to set up your work to use the calculator. I'm not going to do the analytical work in order to allow for the maximum amount of time to explore the features of the calculator. So, let's get started. So I'm going to presume that you're just taking the calculator out of the box and you want to know how to use it. First thing we're going to do is turn it on. And notice that the on key is at the lower left-hand corner. Press on. And then, so that we'll all be in the same place, we're going to go to what's called the home screen. And to get to the home screen, you press the second button and the mode. This activates the quit command. You can see the word quit written in yellow letters right on top of the mode key. Whenever you use this second key and press any of the keys on the keypad, it activates the second function of that key. Now on the home screen, you should be seeing a blinking cursor in the upper left-hand corner of the screen. If you've just turned the calculator on for the first time, that cursor is probably very faint. And so what we'll want to do is adjust the contrast so that you can read your screen well. To adjust the contrast, you press the second key and the up arrow key until you get a contrast that's readable for you. And you may need to do this several times. So let's work through that until we get one that looks good. Now what you're going to notice as you're pressing it, a number appears up here in this corner, any digit from 0 to 9. And each one of those digits appears 4 possible times to indicate the different settings that you might come to. So you need to continue pressing until you can read your screen. And I'm going to stop right here. The cursor should be visible and the background should be light enough so that you can actually see the cursor. This is the screen from which we'll do many of the calculations. Now, if this is not a new calculator and you have gotten it from someone else, there may be some settings in the calculator that you don't want in the screen. So what we'll do is look at how to reset, but before you press anything, make sure that you think about whether or not you want to do it. So I'm going to press second and then the plus key, and you notice that that activates a memory reset. And there are various things you can do. If you want to completely reset, you would press 5, and you see you get a choice to reset all of memory or to reset all of the defaults in the calculator back to the way that they were set at the factory. If you choose all of memory, you can choose it by pressing the Enter key. And yet again, it wants to make sure, do you really want to do this? And choice 1 is no, I don't want to do it. Choice 2 is reset. Now notice it even tells you down here, resetting the memory erases all data and programs. Now I'm not going to reset because I want to keep what's in my calculator the way that it is, but if you choose it, you're going to arrow down to 2 and press Enter. I'm going to go back to 1 and press Enter because I don't want to reset, and that's going to bring me back to the home screen. Now let's take a look at a few other things so that we're all in the same place. Let's look at the graph grid. So press the graph key and you'll see an X, Y axis display. Now if you are not on the same window that I'm on, let's all try to get there by pressing the zoom key. And you see we have several choices. We'll come back to these choices as we're going through some of the problems. What I'm going to choose is zoom standard. There are 2 ways that you can access items on a menu. The way that we just did, by having the cursor on top of the number that you're trying to access and then pressing Enter, or you can simply press the number that you're choosing. In this case, I want number 6, zoom standard, so I'll press 6. Now that's not going to do anything for me because that's where I was already. So what is the standard viewing window? The next key that we'll look at to investigate that is the window key. So press window, and it shows you that the minimum value on the x is a -10, the maximum value is +10, the x scale is 1, and what that indicates is where tick marks would be placed on the x-axis. The y minimum is -10, the y maximum is +10, the y scale is 1, again the tick marks, and the resolution just describes the resolution of the picture. We'll leave this exactly the way it is all the time, but these things we're going to change to accommodate different graphs. Let's look at a few other initial settings, and then we'll actually work through an example. I want you to look at the Format menu, and you see that the word Format is on top of the Zoom key. So to access it, I would press Second and Zoom, and it shows you a couple of choices. We will look at a few, and we'll actually come back to some later. If the rectangle is on top of any one of the choices, it indicates that that's what your calculator is using at that point. In fact, that's the factory default, all the left settings. This indicates what kind of coordinate is going to show when we look at the trace menu, and this is rectangular and polar. We'll look at that. This also refers to the trace, which we'll come back to. Let's come down to this one and see what this does. To get down to this one to do a change, you just arrow down, and if I want to put grid on, I arrow across. And now this is important because it's easy to forget. You need to press enter to actually make that choice, the choice out of the grid off and the grid on. Now let's look at what that does. Press the graph key, and what we get is a point on the whole plane at all of the little tick marks. Most of the time we're not going to want that kind of setting. So let's get back to the Format, reset it with the grid off, and just talk about what the rest of them will do. Axis on and axis off. If the axis is on, then the XY axis will display on your screen as long as it's part of the window that you're displaying. If the axis is off, they won't display on your screen, so we're going to leave it as it is. Label off and label on. This just labels the x-axis with an x, the y-axis with a y. It sometimes gets in the way, so I leave it like this. And the expression on and the expression off is something that we'll use when we also examine the trace feature of the calculator. Okay, now let's take a look at an example now that we've done some initial settings and we're all in the same place. What we're going to do is do some algebra first and then go on to some trigonometry uses. Okay, we're going to start with a linear function, and suppose I wanted to graph the linear function 30x plus 20y equals -500. In order to enter this equation into the calculator, I'm going to need to do some analytical work, and let me show you why. If you press the y equals key, it's called the y editor, that's the one that allows us to enter functions into the calculator. You'll notice that you have this format with y sub 1 equals. So any function that you put in your calculator is going to have to be in the form y equals whatever the expression is. So then I need to take that 30x plus 20y equals -500 and rewrite it into y equals minus the fraction 3/2 times x minus 25. And now we're going to enter that into the y editor. Now notice that there are two negative signs on the keypad. There is this gray negative sign that has a little parentheses around it on a gray key, and then there's this blue one over here together with all the other operation keys. This one down here is the one that we use to indicate that a number or an expression is negative. This one here is the one that we use to indicate the operation of subtraction. Now there are some instances in which the calculator will actually give you an error message if you use the wrong one. There are other instances in which it will just interpret it and use the one that you have given and possibly give you an incorrect graph. So you need to be very careful to use the appropriate ones. Well, on my first negative sign, that's going to be this one because that's the sign of the number. Now, if I put in 3 divided by 2 and then my x, and then minus, and realize that this minus is going to have to be the subtraction minus, 25. Okay. The calculator will interpret this as minus 3 divided by 2 and that whole quantity times x. Now, depending on what calculator you're using, sometimes that doesn't happen. So what I recommend, so that you don't have to remember all the different rules of operations, is to put these things in parentheses in order to make sure that you're entering it correctly. Now, suppose I had entered it like this, and then I realized later, well, I really want to have this 3/2 in parentheses. So what I'm going to do is go back and edit this by using one of the edit possibilities. So what I want to do is have a parentheses right here. I need to then go to the insert command, which is on top of the delete key. So I'd press second, delete, and now it's waiting for me to insert something. I'll insert a parentheses. I need to close the parentheses over here, so I'm going to arrow across, and I want a parentheses right here in the position where the x is. So again, I'm going to insert, and you see what happens when you insert. It inserts your character at the point that you requested and then moves everything else over from there. All right, now let's see what happens if we try to graph this. If you want to actually get that x to stop blinking, just put your arrow down and you can see then the whole equation. You might notice that when you use the gray minus sign, it's a little bit shorter than when you use the blue minus sign. So that can be an indication when you go look over to see if you've entered something correctly to notice what size the sign is. All right, so now I want to try to graph this thing. Remember, I'm on the standard viewing window. I'm going to press graph. Now, you might not have noticed, and we'll look at it again, in the upper right-hand corner, as your calculator is graphing a function or functions, a little line, we call it a snake, revolves around here. And when that stops, that means the calculator is finished. Now, when you look at this, you're not seeing anything on your graph grid. Unless you look very, very carefully, you can see one dot over here in the lower left-hand corner. And that's actually the only piece of this line that's showing in this viewing window. So the standard viewing window then is not adequate to show a complete graph of this linear function. Well, there are a couple of ways you could try to get it to show up. And one way is to do a little bit of analytical work and try to figure out where would it intersect the x-axis, where would it intersect the y-axis, in order to be able to reset your window to get a graph of this line. So let's suppose I would do that. I would come up with an x-intercept of minus 16 2/3 and a y-intercept of minus 25. So you can see from those values that those y minimum and y maximum values of minus 10 and 10 were not sufficient. So let's go back to the window and reset. All right, in order to accommodate that x-intercept of minus 16 2/3, I'm going to enter into the x minimum value a minus 20. And notice that's going to be the gray minus. Okay, I'm going to leave this one the way that it is. I'm going to leave the x scale the way that it is, and then come down to the y minimum. And in order to accommodate that minus 25, I'm going to enter a minus 30. And I'm going to leave these the way that they are. All right, now let's take a look at that graph again. Now you see I'm getting a complete graph that's showing the x-intercept and the y-intercept. Now using this graph, let's look at a few features. The first one I'm going to look at is the trace feature. And that key is up here across the top between the zoom and graph. If I press trace, what happens is the expression that I'm tracing along appears up here at the top. And remember when we were looking at the format menu, we had a choice of having expression on and expression off. Well, this is what it was referring to. I want the expression on so that I can see which function relates to this line. Also remember we had the possibility of showing the coordinates off and the coordinates on. That relates to this right here. So what we can do with the trace is press the left arrow and it goes from pixel to pixel, and as it lands on a pixel it gives you the coordinates of that pixel for that function. So I can move up and down in either direction on the graph. Later, when we have two graphs in the calculator, I'll show you how you move from one function to the next. Okay, now let's look at a couple of other features. We want to be able to verify this x-intercept and this y-intercept using some of the features of the calculator. First, I'm going to do the y-intercept. And to do that, we're going to go to the Calculate menu. And that is accessed by using the second function and the trace key. You see the letters C-A-L-C. So I'm going to do second, trace. And notice that I have several choices. We'll work through all the way to number 5 in the process of going through some of our examples. The first one that I'm going to choose is value. So I'll press 1. And what happens, I get a prompt at the bottom of the screen asking me for an x value. Since I'm trying to get the y-intercept, that's when x equals 0, I'm going to put 0 in here. Okay, and then press enter. And remember, this was the intercept that we got with the analytical calculations. To get the x-intercept, I'm going to go back to the Calculate menu, and I'm going to use the second choice, the 0. This choice allows you to find the 0 or zeros, if there's more than one, of the functions that you graph. So I'll go down to 2 and press enter. Now notice what happens. I get my function still at the top, but I have a different prompt at the bottom. I'm asked for a left bound, and here I have my cursor blinking at this point. So what the calculator is asking me for is a point to the left of this x-intercept. So I need to arrow across, and what you can do to go a little bit faster is just keep that arrow pressed down. Every once in a while you have to pick it up to see where it is, because when you keep it down, it sort of fades off. Okay. All right. So I want to get a point that's to the left of the x-intercept. Now, if it's hard for you to actually see that visually, you can always look down here and realize that for this one anyway, if you're getting a point to the left of this x-intercept, the y-coordinate's going to have to be positive for any point up here, and you see that it is. So that's a good choice. Once you've gotten it, press enter, and that fixes that choice, and in fact even puts a marker right there. So it puts a marker there, and then we're prompted for a right bound. In this case, we're going to do the same thing, but we're going to move the cursor until we get to the right of the intercept. And again, if visually it's a little hard for you to see because the x-axis is in there, in this case, a right bound is going to have a negative y-coordinate, so you know you're in the right place. Press enter again, and look and see that it fixes that point, and then it's asking for a guess. So you can just go anywhere in between. And what the calculator is going to do is use this as a starting point to actually try to determine the x-intercept. Press enter, and then at the bottom of the screen you see the 0. Remember, we calculated it as minus 16 2/3, and so this is just a decimal approximation for it. Now sometimes when you do this and you're working with a friend or looking at your teacher doing it, you could have one decimal place a little bit different over here, but that's all right. That just means that you had a different left and right bound and that your guess was just a little bit different. All right, now before we go on to another example, let's investigate how we could have found this function another way. To find this function, we did some analytical work to get the x and the y-intercept. But how could we have done it another way? Well, first, I want to show you some features of the zoom menu. So press the zoom, and notice that not only do we have this menu, but we have another menu that we can access under the word memory. So I'm going to press the right arrow, and when I do, notice the zoom menu is gone, and I have a whole other menu available. And this is the zoom memory menu. Remember, I chose that x minimum and that y minimum to accommodate this function. Suppose I wanted to save that in case I wanted to come back to it. You see, I have various possibilities: zoom previous, zoom store, zoom reclaim, and set factors. So what I'm going to do is go to zoom store, and all that does for me now is stores that setting in case I want to come back to it. Now, let's try to search for this function in a different way. So what I'm going to do is go back to my starting point, zoom 6, and remember this is what I first got when I graphed this function. And let's say that I want to try to find it without doing the analytical work. Well, what I can do again is use the zoom feature, but a different part of the zoom feature. So I'm going to press zoom and choose zoom out. Now let's talk about what it does before we do it. What the zoom out feature does is take the graph and expand it by what's called a zoom factor. And you saw that zoom factor as that fourth choice in the zoom memory. So if I press 3 for zoom out and then press enter, you see I get the graph to appear. Now this window is different from the standard viewing window, and it's different from the one that I had set. So let's take a look at what this window indicates by pressing window. And you see now instead of having minus 10 to 10, which was a range of 20 units, I have minus 40 to 40, which is a range of 80 units. So it takes the range and multiplies it by 4. Now that's the factory setting for the zoom factor. You can change it yourself by going into that zoom memory menu. Now, how do I go back to that viewing window that I originally picked? You know, suppose, let's go back to graph, and let's say that I had wanted to go back to the one that I had chosen with the minus 30 and the minus 20. Well, to do that, I can go back to the zoom and to the memory menu. Now, while we're here, we might take a look at this set factors that I just talked about, and we'll just come back to this. So I want to look at 4 set factors. I'm going to go down to 4, press enter, and you see there's that 4. Remember I said that it was multiplied by 4. You can make this anything that you want, depending on how you want to operate. All right, let's go back then to the zoom, across to memory, and remember I had used store to store this window settings of the minus 30 and the minus 20. If I want to reclaim them, I can press 3, and you see I get back to the one that I had been in before. The only other setting on that zoom memory, let's go back to it, is zoom previous. If I press that, number 1, it just goes to whatever settings I had been in right before. And remember, I had been in the zoom out settings. Okay, let's look at, add on a little bit and examine some other features of the calculator. So to do this, I'm going to add on another function. Suppose I wanted to determine the point of intersection of 2 functions. Well, I'm going to use my same one that we've been working with, y is equal to minus 3/2 x minus 25. And then I'm going to look at another one, y is equal to the cube root of 5 times x plus pi. Now I chose that rather unusual function so that we could look at some of the built-in features of the calculator, how to get a cube root and where the pi is located. All right, so let's look at y equals, I already have my first function in there, and I'm going to add my next function, cube root of 5 times x plus pi. All right, so I'm going to put that cube root in parentheses. Now how do I get a cube root expression? I can go to the math key, and there are several things, we'll come back to some of them, and here you see just a little 3, that's a cube, and here you see a cube root. We will come back to this one later. This is what I call a generic root. So if you're not finding a square root or a cube root, this is the one that you're going to use, and we'll use it a little bit later. So I'm going to choose number 4. And notice what happens, it's a sort of a cut and paste operation. Wherever you had the cursor, it's going to paste that expression there. Then notice what else happens, it not only pastes the expression, but a parentheses to indicate here is where we're going to start the radicand. In this case, we have only one expression, the 5, but you may have an expression like 5 plus x or 5 times x minus 3, in which case this would really be necessary. I need to close this parentheses, and then x, then plus, and the pi is located on top of this caret key, which we will also use a little bit later. But notice it's the second function, so we need to do second and pi. Okay, now let's go to the graph. And what I want to do at this point is find this point of intersection. Now I'd like to go back to that viewing window that I had earlier. You remember the -30 and the -20? So I'm going to go back to the zoom menu, to the memory, and then reclaim. Because remember I'd stored that so I can bring it back whenever I want it. Now, let's look at a couple of the graphing features of the calculator. Go back to the y=, editor, and you might have noticed this as you were entering functions. To the left of the function you see a line, a straight line, and this indicates how this function is going to graph. I can arrow across to that, and I can change it by pressing enter. Now if I press enter, you see a thick line, and that will just make the graph as a thick line. I'm going to leave that one that way so that you can see the difference. And let's come down to this other one, and we'll investigate some of the other possibilities. If I press enter, it will go to the thick line. If I press enter again, notice it shows a little triangle in the upper half blinking. What this feature does is graphs the function and shades everything above it. And you might need to use that when you're graphing inequalities. Press enter again, and you also see a triangle blinking, but it's in the lower corner. That has the same characteristic. It graphs the function and then shades below. Press enter again, and you see a line, like the first line that we saw, with a little circle. And what that does is the circle actually traces the leading edge of the graph as it's graphing, and then leaves the graph as a line. Press enter again, and in this case you get just the circle. So that if this function would be graphed this way, the circle would only go across the screen to show you where the points are, but no line would be left there. You might want to use this feature if your function represents the motion of some object, and you want to just see the motion as if the object were moving, but then not have the graph of the function. Well, now let's go back. I'm going to press enter. And the last feature is a dotted line. So you can also make it graph in a dotted fashion. When we go back and look at mode, we'll see that we can do that in another way. So what I want to do then, just so that you can see both of these things, is we'll go through on this bottom one until we get to that circle leading the function, and we'll graph it that way. So I'm going to graph. And you see how the circle leads the edge. And if you had used the other, just the plain circle, that circle would be coming across and you wouldn't have any line graphing down there. All right, so we first entered these functions because we wanted to find what the point of intersection is. Now just because I find it a little bit easier to read, I'm going to go back to the y=, editor, and I'm going to change this to a plain old line. And I'm just pressing until I get back to that possibility. I'm going to do the same down here. Sometimes if you press too fast, you can miss it. Okay? And I'll show you something else that you can do to get your functions to graph a little faster. Press the mode key. And notice that there are several possibilities here. We will come back to this one when we're in trigonometry. This just tells you how your numbers are displayed, whether they're in a normal way of writing them, scientific or engineering notation. This tells you how your decimal point is fixed, whether you're going to let it float to however many characters the calculator gives you, or whether you want to cut off at 0, 1, or 2. This gives the function mode. We're going to remain in regular function mode until way at the end when we look at parametric and polar. This is the other way that I told you you could get it to do a straight line or a dotted line, but what we want to come down to is this one down here, sequential and simultaneous. When it's on sequential, the graphs of the functions are done in the order in which they appear in the y equals editor. y1 first, y2, y3. If we do it on simultaneous, then they graph together. And when you have more than one, that might be a good idea just to get it done quickly. Okay, so now how do we find the point of intersection of these two? Go back to the Calculate menu, and we're going to go down to choice number 5. So I'm going to press 5, and notice that I get a prompt. I get a prompt and a cursor on the first curve. So what I do is go close to the point of intersection, and I'm going to give it a guess. I think this is close to the point of intersection. Then it'll hop to the second curve and ask you for another guess. And that's a pretty good guess where it's already positioned. And then it actually asks you, what do you think the point of intersection is? So we press enter. Okay? And the point of intersection is an x value of minus 8.766917 and a y value of minus 11.84962. We're going to actually revisit this system when we do matrices and find this point of intersection a different way. Okay, before we investigate some of the other features using a quadratic function, I want to show you the table feature of the calculator, because this can be really convenient. And to do that, press second and graph. And what you see here is a table of the values of these functions, the y1 and the y2 function. It has x values at 0, 1, 2, 3, 4, 5, etc., and then computes the y1 and the y2 value. Now, it was already preset to start at 0 and do increments of 1, but you don't have to use that particular setting. Suppose you wanted it to do something else. You'd go to the table set feature, which is the second feature on top of the window key. So press second and table set. And you see it was told to start, and these are just the factory defaults, at 0, with a change in the table of 1. I could have put, say, a minus 10 and an increment of 2. Now notice I have indications here for the independent variable and the dependent variable. This is the x and this is the y. And they're both set on auto. So that means it's going to automatically start with x as a minus 10 and increment by values of 2 and automatically compute the dependent variable, the y. So let's take a look at that another time and see if it has done what we wanted it to do. All right, you see we start at minus 10 with increments of 2. Now there's another thing you can do with that table. Let's go back to the table set. And it's this. If you want to compute several different, not necessarily in incremental values of x, and you don't want to use that value command that we found in the Calculate menu, it's a little faster to use this table. And what we do is go down here to the independent variable, go across to Ask, press Enter, remember, and now when we go to the table, you see there's nothing on it. So it's waiting, it's asking for you to put in an x value. So suppose I put in an x value of 5, press Enter, and I get the y1 and the y2 values. Suppose I wanted to put in minus 3, press Enter, and I get the y1 and the y2 values. So that's a good feature to use when you have several points that you want to evaluate, and it's a lot quicker to do it this way than to do it with that evaluate feature in the Calculate menu. Now let me show you something else about it, how you can place it. Sometimes you'd like to be able to look at this table while looking at the graph, and we can do that by going to the Mode key, and we're going to come all the way down here and notice that it's set on full, meaning full screen. I'm going to arrow down, go across to GT, which is Graph Table. We'll come back to this way of splitting the screen a little bit later on. Press Enter, and now I'm going to press Graph and see what happens. I'm getting the graph of my lines over here, and I'm getting the table right here. Now, I'm only seeing the x and the y1 because there's just not enough room to display the y2. But if you arrow across, I have to go to the table actually, it will bring you to the y2. Now notice when you have the split screen, it's a little easy to do what I did just now. I was looking at the table and thinking that I was in it, but I was actually over here in the graphing menu because that's what I had pulled up first. So when you have two pieces, you have to make sure that you're in the right place. So that if I wanted to be over here working with the graph screen, I'd have to press the graph. And when I want to come back to the table, I have to actually ask it to put me on the table. For the next example, I want the full screen again. So I'm going to go back to mode, and I'm going to go back and reset full. Okay? I'm also going to go back to the y equals. I'm going to take out these so that I'll be ready for the next example. And I'm also going to reset the viewing window to standard. So remember that's zoom and 6. Okay, now we're going to look at a quadratic function, and we're going to use this quadratic function to investigate some other features in the Calculate menu, some other ways of dividing the screen, and to show how to do some calculations on the home screen. So the function that we're going to look at is y is equal to 2x squared minus 4x minus 3. So I'm going to go to the y equals menu and put in 2x. There are two ways that I can square an expression or a number. I have this possibility, the x squared key. So if I press that, it simply puts a little square right on top of the x. But what I'm going to do, so I can show you the other way of doing it and also show you this delete key, is I'm going to go back using the arrow, and I'm going to take that square off using the delete key. So that shows you how to take something out that you really didn't want. Now what's the other way to get this in here? Well, to get any power, you can use the caret key and then whatever the power is, in this case 2. Now the square key is just a lot faster for a square. All right, then we have minus 4x and then minus 3. Notice the minus sign that I used was that blue one because that indicates the operation. All right, now let's take a look at that graph. So we see the graph of a parabola. It intersects the x-axis at 2 points, and we're going to come back and look at that. And then it has a vertex down here. Well, if you calculated the vertex using one of your analytical methods, say completing the square, or maybe you use the vertex formula, you'd come up with the point 1, negative 5. Now let's see how we can confirm that point using one of the features of the calculator. So I'm going to go back to the Calculate menu, second and trace. And look at all the ones we've used already. We've used value, we looked at 0, we looked at intersect, and now we're going to look at minimum. The maximum feature works exactly the same way as the minimum feature works. If this parabola had had a maximum point as a vertex, we would be using this one. So we're going to choose 3, and I get a prompt, just like I did for the 0 of the function, for a left bound. So that's a point to the left of the vertex. And this is usually a little bit easier to see than, say, the zeros were on the x-axis. I can get maybe a little bit closer. Press enter. Again, I have the left bound marked like I did on the 0 of the function. I want a right bound, so I'm going to move to the right. Press enter. Again, I get it marked, and I'm asked for a guess again. So I'm going to move to the left and press enter. So I get x equals 0.9999948 and y equals negative 5. You'll see this happening sometime, that you won't get the exact value because this is a numerical iterative process, and it depends on the left bound and the right bound that you chose, and it also depends on the guess that you made. So you may come up with 1 here, or you may not. All right, now what we're going to do is look at how to compute the x-intercepts, both analytically and using the graph. If we were to determine the x-intercepts analytically, we would use the quadratic formula. So for the equation ax squared plus bx plus c equals 0, we would use the formula x equals minus b plus or minus the square root of the entire expression b squared minus 4ac over 2 times a. So for this equation, we would be determining the value of the following. It would be negative of a negative 4 plus or minus the square root of that negative 4 squared, then minus 4 times 2 times a negative 3, and all of that divided by 2 times 2. So at this point, what we're going to do is split the screen the other way and use one part of the screen to view the graph, and then we're going to use the bottom part of the screen to view a calculation. So I'm going to go back to the mode key and come back down here again. Remember, we had split it earlier by looking at the graph in the table. Now I'm going to split it horizontally. Now I'm going to bring up the graph. And you see here's my function graphed. And down here we can put just about anything that we want. I can put the table down there by pressing second and table. But what I want to put down here is the home screen. So I'm going to press second and quit. And remember, this is the screen that we first started on, where we're going to be able to do some calculations. What I'm going to do at this point then is calculate the quadratic formula down here by putting those values in, and then I'm going to come back up here and use the root feature to actually confirm that what I get down here is in fact the root, the 0, the x-intercept of this function. All right, so let's enter those values in the quadratic equation. I'm going to open parentheses, and this is going to be the opening parentheses for the numerator. Then I have the expression minus a minus 4. And remember, I have 2, the plus and the minus. So I'm going to calculate the plus first. Then the square root, we haven't used that yet. There is a built-in square root that's on top of the x squared key, so it's second. And notice it starts you with a parentheses, so that you will begin and write in all the parts of your radicand, and then at the end close it. So I'm going to start with open parentheses minus 4 squared, then the subtraction sign, 4 times 2. And notice that I didn't put a multiplication in there because this kind of multiplication is understood as long as it's in parentheses like that. Times 2, then times a minus 3. And now I need to be careful of these parentheses. This parentheses opened this radical, so I need to close it. This parentheses opened the numerator, so I need to close it. So you always have to have as many left parentheses as you have right parentheses. And most of the time the calculator will give you an error message if you don't. So now I want to divide that by, and I'm going to open parentheses again for the denominator, 2 times 2. And press enter. So I get the value 2.58113883. Now what I want to do is come back up to the graph and use the 0 feature in the calculate menu to see if in fact this point, this x-intercept, is equal to that number. Now remember, I'm down here in the home screen. If I want to get up to the graph, I need to press graph. And now I want to go to the calculate, so I'll do second trace, and I'm going to choose 0, 2. And these are the same prompts that I saw before. I want to get this intercept over here, so I'm going to move over here for a left bound. Now notice in this case, it's a little bit different from that line that was coming across here. In this case, the left bound is actually underneath the x-intercept, so the y value is going to be negative for the left bound. I'll press enter. And then I need to get a right bound. It's doing the same thing we saw before. It fixes the left bound. Go to the right. Again, a right bound is going to be above the x-axis and therefore have a positive y coordinate. I'll press enter. Move in between and press enter again. All right, and see how they're the same. The 0 is 2.5811388, just the way that you saw down here. Now I'm going to go back here and get the negative value, but we'll dispense with computing the 0 since we've done it before, but we might be able to see that we're pretty close just by looking at the value and looking at the placement of that 0. So I'm going to come down here to this screen by going to second mode. Remember, that's the home screen. And what I want to do is recompute this entire expression, but I want a negative sign here. Now I could rewrite the whole thing, but of course in rewriting you have the possibility of copying something wrong and just the time that it takes. But I have a feature in the calculator that allows me to recall this entry. And what I do is press the second button and the enter key. And you see right on top of that enter key is the word entry. And what it does is bring back, you can't see it now because it's scrolled back, it brings back the last entry that you have used. If you press it a second time, it will continue to scroll back to your entries until the last time you hit clear. So I want to get here and change this plus to a minus. So just up arrow, left arrow, and just put the cursor right on top of where I want to change. Now in this case, I'm not going to use that insert the way that I did earlier. I'm going to simply put what I want there, which is a minus sign. Okay? And then press enter. All right, you can see that it comes out minus 0.5811388,301. And if you look at this, it looks like that's approximately what it is. If you go through that whole feature in the calculate menu of the 0, you'll find that in fact it is exactly that value. Okay, now we're going to look at another problem, and the next one is a relation that's not a function, and that's a circle. So we want to consider the equation of the circle, x minus 2 squared plus y plus 1 squared equals 16. Now as I said earlier, the calculator will only accept something written as a function. So what we need to do is rewrite this equation in two parts so that each part is a function. So I would do some analytical work and end up with two functions. One of them is y is equal to minus 1 plus the square root of 16 minus x minus 2 squared. And the other one is almost identical. It's minus 1 minus the square root of 16 minus x minus 2 squared. So to do this graphing, we're going to look at another feature of the calculator that allows us to save a little bit time in getting our work done. But let's do some resetting here. Let's go back to the mode, and I want to come back and give myself a full screen. Let's go back to the y equals and just clear out the function that we have in there. So I have these two functions to graph, and you'll notice that they each contain an identical part. In fact, that square root sign is pretty much the biggest part of the function. So what I'm going to do is enter that whole square root expression into y1. So I press second and square root, and see it opens up for the radicand. Then 16 minus x minus 2 squared, and I'm using that other little square key again, and close the parentheses. All right, so I have just the radical part of those two functions in my calculator. Now remember that the two functions take minus 1 and add the radical, and then the second one takes minus 1 and subtracts the radical. So watch how I'm going to do this. I'm going to go down to y2, and I'm going to put in minus 1. Then what I want to tell the calculator is add, right here, what I have in y1. I want you to just take this whole thing and add it right here. And this is how I can do that. I go to a new key that's going to display a new menu, the VARS key. Press that, and you see I get that situation that I'd seen earlier where there are actually two menus, the VARS and the YVARS. So I'm going to go across to the YVARS, And you see I have displayed here all those y values in the y equals editor. So I'm going to choose 1. Again, this operates like the cut and paste like we saw earlier in the cube root. It just cuts it off of that menu and pastes it right here. Let's do this one, then we'll talk about what the calculator is going to do and actually view the graph. So on the second one, I want -1, but then I want minus this y1. So I'm going to go back through that same process, go to the VARS menu, go across to Y VARS, choose function, and then choose 1. Okay, so I have my radical expression here, and I have my y2 and my y3. These two functions represent this circle. These are the two functions that are needed to make this circle. I don't need this function to make the circle, but I need it to plug into here. So what I want to display is y2 and y3, but I don't want y1 to display. So to do that, I can do what's called turning off the function. And you see on top of your equal sign, you have a box, a stationary cursor. If I go over to those boxes and go up to the one on top of y1, and while the cursor is blinking, press enter. Now let me just go down so that you can see that the y1 equal sign is not boxed in. The y2 and the y3 will be boxed in. So that this one is not going to graph. We call that turned off. And these two will, but they'll have access to this one to use in the graph. Now, to get it, I'm back to the standard viewing window. If you weren't there already, just press Zoom and 6, and your functions will graph. Now remember, we had it on simultaneous, so you had both of the pieces coming around. Now, I said that this was an equation of a circle, but it certainly doesn't look like the equation of a circle. It looks more like the equation of an ellipse. Now, why is that happening? Well, it's happening because if you look at the divisions on the x and you look at the divisions on the y, you see that the divisions on the x for 1 unit are a lot wider than the divisions on the y for 1 unit. That's because you have more pixels this way than you have this way, and you're dividing the x and the y into the same number of units. Remember, from -10 to 10 in the standard viewing window. So to do that, we would need to even out or get these divisions to be equal to those divisions. Now we could work with it a little bit and change the x min and x max to try to get that to happen, or we can go right to the zoom menu and choose one of these that we have not looked at yet, zoom square, and that's number 5. And you see now it looks much more like a circle. But now you do see a couple of problems in that the circle is not complete. See, it doesn't connect here and it doesn't connect here. And you're going to find that in graphing not only things like circles, but in rational functions, and then later when we look at log functions, that what happens is the calculator comes to this point and it's evaluating the x value at this pixel. Then when it goes to evaluate the next pixel, that pixel may not be in the domain of the function. So it just stops, and that's what creates these gaps right here. But as long as you know what the graph is going to look like, then you'll have an understanding that it has to be a complete circle. Now, there's another way that we can get this picture on the screen, and that's by using the draw menu. So let's take these functions off. I'm going to just go back to the graph. And I'm going to access the draw menu by going first to the home screen, second, and quit. And you'll find on your keypad on top of the program key the word draw. So if I press second and program, I get the draw menu. And again, there are a couple of possibilities. I'm going to just use the first part of the draw menu. And there are many things that we can do in here, but we're going to demonstrate how to clear a drawing after we make it, and how to draw a circle. Notice on a menu that if you see an arrow at the bottom, that indicates that there are more possibilities. So to get to that, I arrow down till I get to what I want, which is I want to draw a circle. So I'm going to press enter, and again the cut and paste feature comes along and I get my prompt for a circle. To draw the circle, all I need to do is enter the center of the circle, which is 2 minus 1, So I write 2, a comma, and the comma is right underneath the sign, minus 1, another comma, tell it the radius, which is 4, close the parentheses, and press enter. And this case actually draws the circle all the way around. Now, if we had left our functions up there, it would just draw it right on top of it and actually complete the things. This will only give you a picture. It's just a way that the calculator can draw a circle. You can't use the trace key on this. You can't find intercepts. It only draws the picture. So let's clear that off, and then we can go on to some other examples. I'll go back to the draw and press 1, and you see that clears off that entire picture. Before we can do the next graphing example, we need to investigate some things in the Math menu. And so let's take a look at some of the things we can do. I'm going to press the Math key, and notice that there is a possibility of getting an answer to come out in a fraction. Let's see how this looks, and then we'll come back and use our root key to enter the next function. I'm going to go to the home screen. Let's clear out that draw command. And I want to add the fractions 3/4 and 2/3. So I'm going to put 3/4 plus 2/3. And notice when I press enter, I get a decimal result. Well, if I want to get a fraction result, I'm going to just recall that entry like I had done before by pressing second and enter, and go to the Math menu and choose number 1, which says convert the answer into a fraction. And so I get the answer 17/12. If I wanted to go back to the decimal, go back to the Math menu, and you would choose the decimal result. Now what I want to look at before we enter the next function is this generic root that I had mentioned earlier in the tape. We can get the square root by picking it off of the calculator. We can get the cube root right here in the Math menu, but if we need any other root, we have to use this generic root. And the way that it operates is we put in whatever the root is first. Like if I wanted to take the 4th root, I'd enter a 4, then I'd come back here and pick off this generic root from the number 5 choice, and then enter my radicand after that. So in the next example, what we're going to do is look at a piecewise function. And in this piecewise function, we're going to look at some of the built-in functions that we haven't yet investigated in the calculator. We'll also look at how to limit domains and the features that you need to do that kind of limiting. The function that I'm going to do has 3 pieces. It's y equals, the first piece is 3 times the 5th root of x, and it's that piece for x less than or minus 4. The second piece is minus the absolute value of x plus 2 plus 6, and it's that piece for minus 4 less than or equal to x less than 2. And then the last piece is 2 plus the natural log of x minus 1, and it's that piece for x greater than or equal to 2. Before we put it in the calculator, let's take a look at a hand sketch of this graph in order to have an idea of what's supposed to come up. Because at first what we see in the calculator doesn't look exactly like what we would expect the graph of this piecewise function to resemble. Now let's enter the function. So I'm going to go to the y equals menu, and there are a couple of ways to enter a piecewise function. I find the easiest way to do it is to enter each piece into a different one of the y equals expressions. When we enter a piece and we need to stipulate the part of the domain that that piece holds for, I need to put the function expression in parentheses. So I'm going to open parentheses, and then the first piece that I have is 3 times, and now this is where we have to enter the 5th root of x. So remember, I have to enter the root first. I'm going to put the 5. Then I go to the Math menu and take that xth root by choosing number 5, and it operates in the cut and paste fashion just like we had talked about before, and then x. I can put a parentheses for the x, or I don't necessarily have to put the parentheses for the x. But now I do need to close this parentheses that I opened. Okay? Then after it, I'm going to put the stipulation on the domain. I need to open the parentheses again. It's x. And I need to find a less than symbol. And you find the less than symbol in the test menu, and the test menu is the second function on top of the math key. So it's second, and I choose number 5. Then a -4, and close parentheses. So that's the first piece. Then I'm going to enter the second piece by going down to y2. And again, the way that I put this one in parentheses, I need to put the second piece in parentheses. So I'm going to open parentheses, then I have that negative sign, and now I need to get the absolute value. And this is where you find the absolute value. Go to the math key, and you see there are a couple of other menus there. Go across to NUM, and in there you see the absolute value. So choose number 1. And now I enter the expression. Notice it gives me a parentheses, so I'm going to enter the expression x plus 2, close the parentheses, then I add the 6 and close the parentheses again. That's to close the expression. Now the next stipulation on the domain, -4 less than or equal to x less than 2, I'm going to enter in 2 pieces. The first piece will be open parentheses, -4. I need to get the less than or equal to, so I go back to the test menu, choose number 6, that's the less than or equal to, x, close that parentheses, and then I'm going to enter the other half, open the parentheses, and that will be x, go back to the test menu, choose less than 2. Okay? Now I'll go back to the third piece, and it would be open parentheses, 2 plus the natural log, and there are 2 log keys, the natural log and the common log, natural log of the expression x minus 1, close the parentheses, and now I need to close the parentheses that open the expression, and then put the domain stipulation. For x, back into the test menu, greater than or equal to would be 4, then 2. Now it's a good idea after you've entered so many pieces like this with so many parentheses just to take a quick look to make sure that you've got the parentheses around the expression, the parentheses around the domain, all the way down. If you don't, when you try to graph, you'll get an error, and it will bring you back to where the error is in your entries. Okay, so what I'm going to do at this point is press graph and see what I come up with. Now, this looks sort of like my hand-drawn graph, but there are some problems. Remember, my hand-drawn graph stopped here and then started up there, so I didn't have this piece in it. This piece looks good and this piece looks good, but I have this piece coming down. So let's go back and make sure that everything is entered correctly. Okay? And what I can do then is go to the mode and come down to the other way of changing the way the graph is drawn, connected and dot. And if I write it, change it to dot, and try graphing again, I get the first piece, then the second piece, and then the third piece to connect. Okay? Now go back and just take a look and see what you've done there. You've graphed this piece and stopped it, and then you've graphed this absolute value piece and then stopped it, and then graphed this log expression and then stopped it. Now, you might have noticed, or you might not have noticed, that there was a little bit of problem. Go back to the graph. in that it looked like there was this little extra piece that was in there that didn't belong, and in fact it did not belong. This piece of the graph was not graphing correctly, and I'm going to show you why. If I go back to the y equals, look at what happened down here. I have 2 plus the natural log of open parentheses x minus 1 and close parentheses. I've got too many parentheses in here, so I'm going to go down and delete one of those and then graph again. And you see that little piece that was disturbing the graph is no longer in there, and that was created by adding a parentheses that did not belong. Okay, in this last function that we graphed here, we looked at the natural log, and I also said that there was a log key. What would you do if you had to graph a function that was not a natural log or that wasn't a common log, but was a log to another base? So for example, if I wanted to graph the function y is equal to log to the base 2 of x plus 3, how would I do that? Well, what I need to do is be able to rewrite it so that I can use either the natural log or the common log key. And I would use the change of base formula for that. Recall that the change of base tells us that if we have an expression log x to the base a, I can convert it to log x to the base b divided by log a to the base b. So when I go to graph that log to the base 2 of x plus 3, this is what I'm going to enter. Let's clear off all these functions. I'm going to enter the log of the expression x plus 3 divided by the log of 2. Now I could have used the natural log here as well as the common log. What I did was use the base changing formula to change to the base 10. Remember, x plus 3 was the expression, and then the 2 was the base. Now I see a couple of editing problems I'm going to have to do here. I need a parentheses there, and then I need to go up and deal with that same problem that I had in the last one, in that I added that extra parentheses, because the log expression automatically opens the parentheses for you. Okay, so now let's press graph and see what that looks like. Okay, I get a reasonable graph of the log function, but it doesn't graph it all the way down as you know that it does. Remember, the log function approaches an asymptote at this point, but it stops, and I have the same problem here as I had with the circle. When it goes to evaluate the next pixel on this grid, it's not in the domain of the function, and therefore it just stops. So you need to understand that the actual graph of the function continues to go and understand the limits of how you can graph on the calculator. Now I want to go back and change my mode. It didn't affect this problem. Back to connected, so that the rest of the functions that I graph will be connected lines rather than dotted lines. We have one other algebra function to graph before we go on to some trigonometry examples. And this one is going to demonstrate quite a few different features on the calculator. And it's a rational function, and that is y is equal to, in the numerator, x squared minus 4, and in the denominator, x squared plus 3x plus 2 multiplied by x minus 4. Now, if you were graphing this without the calculator, you would need to do a little bit of preliminary work. And the first thing you do is factor the numerator and factor the denominator. So the numerator and denominator would factor into x minus 2 times x plus 2 divided by x plus 2 times x plus 1 times x minus 4. You would see that there was a common factor, x plus 2, in the numerator and the denominator, and divide it out. And what that is ultimately going to do to the graph is to create a hole in the graph. There won't be any point for the function at the value x equals minus 2. Then you would take the function reduced, x minus 2 over x plus 1 times x minus 4, do some analysis, and graph it. So your analysis would tell you that there is a horizontal asymptote at y equals 0. There are two vertical asymptotes, one at x equals minus 1 and one at x equals 4. There's an x-intercept at 2, 0. There's a y-intercept at 0.5, and as I had mentioned earlier, there's a hole at the value x equals a minus 2. Now let's enter the function before the simplification and see what it turns out the graph will appear at first. So I'm going to press y equals and clear out that log function. So first I'll put in a parentheses to open the numerator, and it's going to be x squared minus 4 divided by, and I'm going to open a parentheses for the denominator, open a parentheses for the first expression in the denominator, so that it will be x squared plus, got the plus 3x plus 2, close parentheses, open the parentheses for the next expression, x minus 4, and I need to close that parentheses for the expression, and then I need to close the parentheses for the denominator. All right, now I'm going to just reset the standard viewing window, zoom 6, and see what this graph looks like. Okay, it looks like it has some of the features that we might expect. We expect it to have a vertical asymptote here at x equals minus 1. We expect it to have another vertical asymptote here at x equals 4. We expect it to have an asymptote here at y equals 0. But the whole graph in general it doesn't really give us too much of an indication of what this function looks like. Also, I'm not seeing a hole here at x equals minus 2 as I would have expected. There is a way that you can get a better looking graph for a rational function, and that's by using a feature in the zoom menu. So let's go to the zoom menu, and we're going to choose the Z box or the zoom box feature. And what the zoom box feature allows us to do is draw a box around the piece of the function that we want to have a little better view of. So I'm going to choose that, and it's a little bit hard to see, but you see a little 1 pixel cursor blinking down here. What I'm going to do is use that cursor to draw a box around this part of the graph, what I would like to be blown up so that I can see it in a little bit more detail. So this is how you do it. You press the up arrow and watch that cursor. And what I want to do is get it to be a little bit past where this curves. You see how the graph is curving there? And I want to go to the left. Now you can see it better. And I want to get a little bit to the left of this part of the curve in the graph. So I'll just go maybe one more. And I want to fix this point as the upper left-hand corner of the box. So I press enter, and that turns into a little square cursor. Then I need to fix another corner of the box. So I'm going to press the right arrow, and you see it's starting to draw. You can hold the arrow down to make it go a little faster, but you see that it disappears at a point, so you have to pick it up to see where you are. So I'm going to bring this a little bit to the right of the curve, and now I want to come down and fix my bottom boundary. And now before I press enter, let me explain what's going to happen. When I press enter, I will fix this box, and this box will then expand over the whole viewing screen so that I'll get a much better view of this piece that I've boxed in. Okay? So you can see the asymptotes clearly. You can see how the graph curves. Okay? You can see the intercepts, and you can see this curve. So it gives a much better view than that last one that we saw. And this is a technique that you can use for all the rational functions. You want to box the appropriate part of it so that it magnifies it for you. Now what we don't see here is a hole at the point minus 2. And that's because in this particular viewing window, there isn't any pixel at the value x equals minus 2. We can get one, though, by looking at the zoom menu again and changing it slightly to decimal. And in the decimal viewing window, the pixels evaluate for every tenth. So I'm going to choose number 4. And you can see it's a little bit of a different viewing window. The asymptotes don't show up in this case. And the asymptotes are just an attempt of the calculator to connect the different pieces of the function. But we do see that there is a hole at x equals minus 2. The reason for that is that we are evaluating, and we can look at that by pressing the trace key, at every tenth. Now watch as I go along. You see how the x value is changing just by tenths? I'm going to go to the end of this piece and it'll hop on to the next piece. Now watch as I get to, see every place that I've gone I've had some values, but as I get to this one where it says x equals minus 2, there's no y value. You might have noticed that where we would have an asymptote, that would also be the case. Our last algebra application is going to be a demonstration of the matrix feature of the calculator. So what we're going to do is go back to that system of equations that we had worked with earlier. Remember, we found the point of intersection using the calculate menu and the intersect feature. Well, what we're going to do now is use matrix evaluation and actually solve the equations using a matrix equation. So you might want to refer back to that point of intersection to see that what we're going to get here is going to match up with what we got there. Okay, recall that the equations were y is equal to minus 3 halves x minus 25, and the second one was y is equal to the cube root of 5 times x plus pi. Remember, the intersection point was, for the x value, minus 8.766917, and for the y value, minus 11.84962. In order to solve this using a matrix equation, we're going to have all the variables on one side and a constant on the other side. So I would rearrange the equations so that they read 3 halves x plus y equals a minus 25, and minus the cube root of 5 times x plus y equals pi. Then I'm going to need to rewrite this system as a matrix equation, and it would appear as follows. In the coefficient matrix, I would have 3 halves, 1, in the first row, and minus the cube root of 5, 1, in the second row. In the variable matrix, I have x and y, and in the constant matrix, I have minus 25 and pi. So I have this set up. I have a matrix A, the coefficient matrix, times a matrix X, the variable matrix, equal to a matrix B, which is the constant matrix. Now recall from matrix work that if you want to solve this, what you need to do is multiply both sides by the inverse of matrix A, provided the inverse exists, and then we would determine the values of the variable by multiplying A inverse times B. So let's now put these matrices in the calculator. We'll find out if matrix A has an inverse by evaluating its determinant. Okay? So I'm going to now clear off some things that we have. I'm going to clear off the functions, go back to the home screen and clear that off because we're going to be using it for the calculations. And now look at the matrix menu. So we pull up the matrix key, and it shows us 3 choices: names, math, and edit. The names choice is what we use to actually say, okay, we want to have matrix A to use in our calculation. The math choice, I'll show it to you and we're going to come back, allows us to do a few calculations on matrices. We're going to come back and use the determinant. This one would give you the transpose. But what we need to do now is go to edit, and that allows us either to change something in an existing matrix or to create a new one. So in matrix A, I'm going to write the values that we have for our matrix A. So I choose number 1, and what it does is set me up to enter values. Now it's going to set me up initially with a 1 by 1 matrix, but you just have to adjust it for whatever the dimensions of your matrix are going to be. In this case, it's a 2 by 2. So I'm going to write over a 2, press enter, and another 2, press enter, and it brings me right to the entry in the first row, first column. So I'm going to enter in there 3 halves, and notice it comes down here at the bottom. When I press enter, then I see it in the matrix itself. The next entry is 1, comes down at the bottom and in the matrix itself. And then I come down to the next row, and I need to enter minus the cube root. And remember that we find the cube root in the math menu, so go to the math menu, choose 4, enter 5 and close the parentheses, and then the last entry here would be 1. All right? So that matrix is then fixed. I'm going to go back to the home screen. If I try to create matrix B at this point by going back to the matrix menu, it could paste it right in here over matrix A, and it gets a little bit confusing. So I've got matrix A. I'm going to go back to the home screen, then go back to the matrix menu, and the second one I'm going to create is matrix B. But let's go back up. We want to create it, so we need to go to Edit and choose matrix B. Okay? Again, I have to specify the dimensions. This one's going to be a 2 by 1. And my first entry is a minus 25. And my second entry is pi. Okay? All right, go back to the home screen. Now remember we said we could use this method as long as A inverse existed. And to determine that, we need to see if the determinant of A is non-zero. So we're going to use the matrix menu again, but go across to Math and pick Determinant. Now we want to evaluate the determinant of matrix A. This is where I use the Names feature. So I go back to the matrix menu and choose under Names. See, now I'm under Names. I used Edit to create. I use Math to do computations, and I use Names to call the matrix back. Choose number 1, and then close the parentheses and press Enter. Okay. The determinant is non-zero. That means I can use this method. Well, now, once you've entered them in, it's a simple arithmetic calculation. At this point, I want to compute A inverse, so I need to go back to the matrix menu, under Names, because now I'm simply pulling it up. I'm not rewriting it. Choose 1, and I want to get the inverse of that. All I need to do is press the inverse key, then multiply it by matrix B. So I go back to the matrix menu, choose number 2, and then press Enter. And those are the values that we looked at before that we got when we did this by getting the intersection of the two lines. All right, now we're going to switch to trigonometry for a while. Your calculator can handle trigonometric calculations and functions in 2 different modes, and we might want to take a look at that. If you go to the mode key, you'll see that it can handle it in radian and in degree mode. It's preset for radian, so you need to move it if you want it in degree mode. We want to use radian mode at first, so if you have changed it in any kind of way, then put your calculator in radian mode. What we're going to do is graph a trig function, y is equal to 6 plus 3 times the sine of 2x minus pi over 3. If we were graphing this without the calculator, we would determine the following information about the function. The period is pi, the phase shift is pi over 6, the vertical translation is up 6, and the amplitude is 3. Suppose I wanted to graph this over 2 periods, say. I could start at pi over 6, the beginning of the phase shift, and end at pi over 6 plus 2 pi, 2 of the periods, which equals 13 pi over 6 by the time you add those 2. Before I would make any adjustments to the viewing window, let's look at another viewing window that we haven't actually examined yet. So I'm going to go back to the window, and notice that we're set on the decimal viewing window. Go to the zoom key, and we've looked at zoom box, zoom out, Zoom in operates the same way. We've looked at zoom decimal, we looked at zoom square and zoom standard. The one we're going to look at now is zoom trig. So I'm going to press 7. And what I'll do is go back to the window and see what it gives me. The x minimum on the trig window is minus 6.15, the x maximum is 6.15, and those are close to minus 2 pi and 2 pi. So that's a standard window that you can use. Most of the time you're going to want to adjust it to an appropriate window to graph your function. And that's what we're going to do right now. So what I'm going to do is change and put my x minimum at pi over 6. And I'm going to put my x maximum, remember I had said to graph 2 periods it would be pi over 6 plus the 2 pi, which is 13 pi over 6. I'm going to leave the x scale the way that it is, and I'm going to, for right now, just leave the y minimum and the y maximum the way that they are. And if I did that, though, I would get a piece of my graph, but not a complete look at the entire graph. So perhaps it would be a good idea, before we look at the function, to change the y minimum to 3, and we'll change the y maximum to 9. What this will allow is for the entire period to show, and it will put a complete graph and spread it over the whole screen. So now let's look at the function and see what the graph looks like. So we have 6 plus 3 times the sine of the expression. Once again, I put a parentheses where I didn't need it. 2x minus pi divided by 3. Okay, so I have 6 plus 3 times the sine of the expression 2x minus pi divided by 3. And now let's see what that looks like on the window that we set. Okay, so you see 2 periods as the first period and the second period graphing, and because of the way I set the window, it allowed me to get a maximum use out of my screen. See, if I'd done minus 4 to 4, remember how we had originally had it, I would have seen this, but then I would have cut off up here. So you'll determine those values by determining the amplitude of your function. We can also use the trigonometry features of the calculator to confirm the solutions to trigonometric equations. So let's consider the following equation. Suppose I wanted to solve cosine x equals 0.5 in the interval 0 to 2 pi for x. If you did an analytical paper and pencil solution to the equation, you would get the following results. We would get pi over 3 that has a decimal value of 1.047197551, and then you would get 5 pi over 3, which is 5.235987756. To graphically support this solution, we could do one of two things. We could graph cosine x as y1 and 0.5 as y2 and find the point, or in this case, points of intersection, just like we had done earlier on those straight lines. Or another method to do would be to take that equation and subtract the 0.5 from both sides so that we get cosine x minus 0.5 on the left side and 0 on the right side. If I then graph that function, the x-intercept or x-intercepts of that graph would be the zeros of the function. I'm going to do it that way because I want to show you a little method that I use that I call sort of eyeballing the answer, not necessarily getting the exact answer. So what I'm going to do then is go back to the y equals menu and clear out that function and enter cosine x minus 0.5. Let's backtrack here. I'm going to insert a parentheses and insert a minus. Whoops, it looks like I've got my minus in there that I need to delete. And then I need to insert a decimal. Now what would have happened if I had not correctly put my parentheses around this x and let it be around this minus 0.5, it would have taken the cosine of the entire expression, x minus 0.5, and that would have been different from the equation that I was trying to solve. So you need to make sure that the parentheses are in the correct place. Now remember, I wanted to solve that over the interval 0 to 2 pi, so I'm going to go back to the window and reset the x minimum at 0 and set the x maximum at 2 pi. Now what I'm going to do is set the x scale at a value that's going to allow me to pretty much see these solutions that I already got. And the way that I'm going to set it is to put it at pi divided by 3. Remember that the two solutions that I got were multiples of pi divided by 3. One was pi divided by 3 and the other was 5 pi divided by 3. So if I put my scale at this, I'll see tick marks at pi over 3, at 2 pi over 3, etc. So I should be able to read that, those solutions fairly easily. I'm going to change this y minimum and this y maximum to a minus 2 and a 2. All right, now let's take a look at the graph. And remember, I had set my tick marks at pi over 3. So here, the function crosses the first time at pi over 3, and you have 2, 3, 4, and it crosses again at 5 pi over 3. Now what you can do for this, just like you did for the quadratic equation, we could actually compute the value by splitting the screen and then checking it up here. So we'll do that for this one right here. Let's go to the mode key, go down and split the screen. And I'm going to do a slight adjustment on the window. And the reason that I'm going to do this adjustment is when I go to evaluate this 0 right here, remember that I always get something written across the bottom of the screen prompting me for the left bound, the right bound, etc. Well, if it's this low, then my graph is going to be overlaid with some of these values and it might get a little bit confusing. So what I'm going to do is go to the window and see how the window pops right up there. And I'm going to change the y minimum to a minus 3. And I'm going to just leave the y maximum where it is at 2. And what that's going to do is essentially raise this up and give me some more room down here. So let's take a look at that. Okay, now I want to use this area to actually figure out what my first answer was, that pi over 3. So I need to put the home screen in this area. And I'll do that by doing second quit. And you see I've got my home screen there. So what I'm going to do then is take the cosine inverse of that 0.5, and I get 1.047197551. If I want to verify that's pi over 3, I can do this. Okay, and I see that it is. But then what I want to verify is that my graph is actually intersecting at that point. So I'm going to do this just the way that I did the zeros for the linear function and for the quadratic function. I need to go to the graph. I need to go to the calculate menu. I'm going to choose 0. And remember, move over and get your left bound. Press enter. Get the right bound, press enter. Move it over a little bit for the guess. And you see that the values are the same. This just rounds it off after this decimal point. Now, there are some other things that you might want to look at, some things that you can use in trigonometry. So let's take a look at the angle menu. We'll take a brief look at that. So I need to go back and give myself a full screen. And I'm going to go back to the home screen. What I want to do is take a look at what the angle menu has in it, and the angle menu is on top of the matrix key by pressing second and matrix. And then we'll come back and actually use some things in the angle menu. It has a little degree symbol, it has a minute symbol, and a radian symbol. What these two will allow us to do is if we're in radian mode but want to do one calculation in degree mode, say, we can leave it in radian mode and for the specific calculation just tack on that little degree symbol and it will just for that convert to degrees. Same thing is the case for this radian mode. What number 4 allows us to do is take an angle written in decimal form and convert it to degrees, minutes, and seconds. So let's see how to use those. Suppose we had an angle, though, written in degrees, minutes, and seconds. Say it was 43 degrees, 30 minutes, and 42 seconds, and we wanted to rewrite it just in decimal form. All right, let's go to the home screen, and I'm going to write 43, go to the angle menu, tack on the degree, 30, go to the angle menu, tack on the minute, and then the last thing is 42 seconds. And you might recall that the angle menu didn't have a second indicator on it, so what we have to use is these quotes down here on top of the plus key. To access anything that's this kind of a blue-green color, you're going to use the alpha key. In most cases, it's actually an alphabet that you're accessing. So you do alpha, okay? Now if I press enter, that's going to convert that to a decimal representation. If I want to go back to the degree representation, I can go to the angle menu and choose number 4. And what this does, and this is something that we haven't done yet, notice that I didn't either recall the entry or ask for anything to happen. I just went right back and tacked on DMS. What happens is whatever is stored in the answer, ANS, is brought down, and whatever action you ask to be done here will be done at that point. So you see I press enter and it converts it back to the degrees, minutes, and seconds. You can use this in other instances if you have an answer that you have to multiply by something. You can just put in whatever operation you want and press the enter and it will automatically take the answer and do that calculation. Okay, now we're going to take a brief look at 2 other graphing modes, the parametric mode, and we'll do that by going to mode and come down to parametric and press enter. And what I'm going to use to demonstrate this mode is just a simple graph of the unit circle. And the unit circle is a circle that has center at 0, 0 and radius 1. Okay, now let's look at what happens when we do this change. We'll go to the Y editor and see that I no longer have Y1, Y2, but I have X1t and Y1t. So in X1t, I'm going to enter cosine t, and in Y sub 1t, I'm going to enter sine t. All right, now I'm going to go to the window and do a few settings. I want the t minimum to be at 0, which it already is, and the t max to be at 2 pi, which it is, but I'll just do it to demonstrate. So I put in 2 pi, and I want the t step to be at pi divided by 36. Now what's going to happen here, I'm going to change the x minimum to a minus 3. I'm going to change the x maximum to a plus 3. I'm going to put the x scale at 1, make the y minimum minus 2, and the y maximum plus 2. I've done this designation to get a square-looking window. What's going to happen, let me go back so we can describe it in terms of what we're seeing. Starting with a t value of 0, I'm going to evaluate the cosine of t and the sine of t, and then plot the point, which would have cosine t as first coordinate, sine t as second coordinate. Then, by going through incremental values of pi over 36, I'm going to go all the way around, and what it will do is graph a circle. All right? So let's now press graph, and you can see the graph as it develops. Now if I do the trace on this one, I see the 2 functions, cosine t and sine t, the t value, the x value, and the y value. If I go around, it gives me the incremental values of t, and then what you get when you evaluate the cosine t is the x-coordinate and the sine t is the y-coordinate. Before we do one more graphing example, let's look at the complex menu, which is underneath the math key, and see what we can do with that. I'm going to press the math, and remember we've used some things in here. We looked at one thing in here when we looked at the absolute value. We're going to go across to this menu. And you see a couple of features here. This delivers the conjugate of a complex number. This delivers the real part. This delivers the imaginary part. If you're given a complex number in XY form, you can get the angle here, and you can get the absolute value of it here. So let's take a look at this one, and we'll take a look at these two pieces here. I'm going to go to the home screen, clear it off, and what I want to do is get the conjugate of a complex number. So I'm going to go back and pick up conjugate by pressing 1, and I'll put in, say, 3 plus 4 times I. Now the I is down here at the bottom on top of the decimal key, so it'll be second and I. Close the parentheses. And so what we expect to happen, the conjugate of this is 3 minus 4i, and we end up with 3 minus 4i. Now let's look at those other two possibilities for getting the angle and the absolute value if I'm given the complex number in rectangular form. So suppose I want to take the complex number 2 square root of 3 plus 2i. And in this case, I would like for the angle to come out in degrees. So I'm going to go to the mode where I have it in radian, and I'm going to switch it over to degrees so you can see what that looks like. Okay? Go back to the home screen. And what I want to do first is get the angle that goes with this complex number. So I'll press 4, and then I simply enter the number, 2 times the square root of 3. Remember to close that parentheses. Then plus 2i, close the parentheses, okay? And then press enter. And so it's an angle of 30 degrees. If I want to get the absolute value, I go back to the math menu, go across, choose 5, and then re-enter the number. Whoops, did some wrong pressing there. Let's go back to the home screen. So I have 2 times the square root of 3 plus 2 times. What happened was I sort of missed the key and I pulled up the catalog, which we will actually look at in a minute. The I is on top of the decimal, so it'll be second I. Close the parentheses, press enter, and so we get the absolute value of 4. The last thing that we're going to look at is a function graph in polar mode. And we're going to look at the graph of r is equal to 7 times the sine of 2.5 theta. So I want to go back to the mode key, and I want to change into this third polar expression to graph a polar function. We want to be in radian mode for this, so I'm going to go back to mode and put it in radian mode. So now I'm graphing in radian mode and in polar mode. We've done most of our work in function. We did one in parametric, and now we're doing this last one in polar. Now look at what the y-editor looks like. I've got R1, R2 through R6. So I've got my R equal to 7 times the sine of 2.5 theta. Okay, what I'm going to do is graph this in a standard viewing window. So Doom 6. And now it looks like there might be some other pieces, so I'm going to go back to the window and adjust and make this 4 pi. And you see it finishes graphing out the rest of the rows. Now I can leave it like that, or if you want to look at it with the X and the Y divisions the same, we could go to the zoom menu and press square for number 5. Okay, and so there we have it a little bit squared off, a little bit more symmetrical in both directions. Now I'm going to go back to the home screen. With the problems we have done, we have gone through many keys and many of the menus in the TI-83 calculator in a very short amount of time. So don't be discouraged if you can't remember where everything is, or if you can't find the points and the keys and the menus immediately. You may want to take this video and go back through it piece by piece and review some of the concepts, possibly even change some of the numbers so that you're doing different problems to see what your calculator does with the different problems. There are some references that you can use to find things if you can't quite find what you're looking for when you're working with the calculator. You have in your manual, there's a menu map in the back, and there's also a table of functions and instructions in the manual. In addition to that, there is a catalog feature, and that's what I had accidentally pressed just a minute ago. And let's take a look at what the catalog does for you. On the bottom of the calculator, on top of the 0, you see the word catalog. So if you press second and catalog, what the catalog is a listing of various possibilities. See, there's that absolute value that we got off the math menu. It's in alphabetical order, and you can just page down until you find what you want. But if you know for sure that what you want, say, starts with the letter R, you can just press the letter R, which is on top of the multiplication key, and it'll bring you up to the first R entry. Notice that it's in alpha mode already, so I didn't have to press the green key in order to get the R's to show up. The rest of this shows symbols. If you want to get to the beginning of the symbols, you press the theta key, which is on top of the 3, and it brings you to the first symbol, which is the factorial. You'll probably want to review this tape several times in order to get familiar with the keys and the menus that we have been using. After you've worked with it for a while, this calculator is going to become the excellent learning aid that it should be for you as you work through your algebra and trigonometry problems.